Hello, today we're going over section 7.7, solving logarithmic equations. In this video, we'll talk about the one-to-one property and do problem number 3. So what does it mean to be one-to-one? The log base b of x equals the log base b of y. Notice there's a log base b on both sides. And what did we talk about? Undo by raising both sides to the base. They're the same base, so b to the log base b will undo each other, and x equals y. Any kind of logarithm. If you have the natural log of x and the natural log of y, then you can raise both sides to the base of e, and they'll undo each other, and x equals y. That's the one-to-one property of logarithms. Let's look at an example. What if I had the log base 7 of x squared equals the log base 7 of 16? I could just raise both sides to the 7. Boom, undone. X squared is 16. X is plus or minus 4. Now, negative 4 is an extraneous solution because you can't take the log of a negative. And so 4 is your solution. Let's try problem number 3. I see log base 4 equals log base 4. How do I undo logs? With exponents. So I raise both sides to that base of 4. Those undo each other. And I see that 4x minus 1 equals 2x minus 5. Now I move the letters to the left, numbers to the right, and I'm set. So subtract 2x from both sides to get 2x and 0, and then add 1 to both sides to get negative 4 and 0. So 2x equals negative 4. Divide both sides by 2, and you see that x equals negative 2. Can that be true even if it's negative? Yes, because look what you're doing inside the parentheses. You're multiplying x by something and adding x to something else. So let's see if this will work out. Don't forget to check for extraneous solutions. It could be a negative 2 if something else is happening. Let's look at the right side. If I plug in negative 2 times 2, this would be negative 4 minus 5. That's a negative. Uh-oh, I can't do that. If I plug in negative 2 and it makes it positive, you can take the log of a positive. You're fine. Just make sure that you check. If I plug in a negative 2 in the original equation, then I will get an extraneous solution. So what do I know for problem number 4? There is no solution. All right, let's look at B. Okay, so natural log, natural log. I can just raise both sides to the base of e, and I'm set. Undo, raise both sides to the base of e. E to the natural log will undo each other on both sides, so 2x minus 1 equals 9. Now that's the same idea as saying, oh, the one-to-one property of logarithms. So if that makes sense, you don't have to raise both sides anymore. You just look and know. Boom, 2x minus 1 equals 9. Then you add 1 to both sides, and 2x equals 10, and divide by 2, and x equals 5. Could this be true? Let's see. So I plug it back in. 2 times 5 is 10, minus 1 is 9. Natural log of 9 equals natural log of 9. So yes. I hope that helped. We'll see you again. Bye-bye.